Greetings, curious humans! Welcome back to our channel, where we embark on incredible journeys through the cosmos. Today, we're venturing into the vast and mysterious realm of the outer solar system to explore a place of wonder, a moon like no other, Europa. Europa, one of Jupiter's fascinating moons, has intrigued the imaginations of astronomers and space scientists for decades. Its icy facade conceals secrets that could revolutionize our understanding of the potential for life beyond Earth. What makes Europa truly remarkable is its hidden ocean, an immense body of water that lies beneath the icy crust, possibly harboring all the essential ingredients for life as we know it. As we stand on the brink of a new era of space exploration, NASA and other space agencies are gearing up for a thrilling mission to uncover Europa's hidden treasures. In this video, we'll delve into the latest discoveries about Europa, exploring its enigmatic surface features, the tantalizing hints of its subsurface ocean, and the ambitious plans to send probes to unlock its secrets. Prepare for a visual feast as we take you on a virtual journey to the icy moon, showcasing its stunning landscapes and the quest for answers that lies ahead. So, don't forget to hit that subscribe button and ring the bell to join our community of space enthusiasts. Together, we'll embark on an adventure across the cosmos, discovering the marvels of our universe, one celestial body at a time. Get ready to be amazed by the wonders of Europa. Let's start this cosmic journey together. Europa, also known as Jupiter 2, is the smallest of Jupiter's four Galilean moons and the sixth closest to the planet among the 95 known moons. It is the sixth largest moon in the solar system. Discovered by Simon Marius and Galileo Galilei, Europa was named after Europa, the Phoenician mother of King Minos of Crete and lover of Zeus. This moon is slightly smaller than Earth's moon and consists of silicate rock with a water-ice crust and a probable iron-nickel core. Europa possesses a thin atmosphere primarily composed of oxygen. Its surface is strikingly smooth with light tan cracks and streaks, and relatively few craters. Scientists hypothesize the existence of a subsurface ocean, possibly harboring extraterrestrial life, due to the apparent youth and smoothness of the surface. Tidal flexing is believed to maintain the ocean's liquid state, causing ice movements akin to plate tectonics and absorbing surface chemicals into the ocean below. Europa's potential habitability is further supported by observations of sea salt coating geological features and the detection of water vapor plumes akin to Saturn's moon Enceladus. The Galileo mission, launched in 1989, has provided significant data on Europa, but no spacecraft has yet landed on its surface. The European Space Agency's Jupiter Icy Moon Explorer, JUICE, launched in April 2023, including 2 planned flybys of Europa, while NASA's Europa Clipper is expected to launch in October 2024, potentially followed by a lander mission based on its findings. These ambitious missions aim to unlock the mysteries of this enigmatic moon and explore the possibilities of life beyond Earth within its subsurface ocean. Europa, one of Jupiter's 4 large moons, was discovered by Galileo Galilei on January 8, 1610, along with Io, Ganymede, and Callisto. Its name is derived from Europa, a Phoenician noblewoman in Greek mythology, and it, like the other Galilean moons, is named after a lover of Zeus, Jupiter. Europa orbits Jupiter at a distance of about 670,900 kilometers, completing its orbit in just over 3.5 days. Its orbit is nearly circular with a small inclination relative to Jupiter's equatorial plane. Europa is tidally locked to Jupiter, meaning one side always faces the planet, and it is believed to have a subsurface ocean due to tidal heating. The slight eccentricity of its orbit causes tidal flexing, generating heat that keeps the ocean liquid and drives geological processes beneath its icy crust. The moon's surface is smooth and covered in cracks, possibly formed by the stresses caused by the massive tides in its global ocean. Recent research suggests that Europa might have undergone a tilt in its axis, which could impact its geological history and the age of its ocean. Europa's mysteries have fascinated scientists for centuries, and ongoing missions, like the Jupiter Icy Moon Explorer, JUICE, and Europa Clipper, aim to unravel its secrets and explore the potential for extraterrestrial life within its hidden ocean. Europa is slightly smaller than Earth's moon, making it the 6th largest moon and 15th largest object in the solar system. Despite being the least massive of the Galilean satellites, it outweighs all known moons in the solar system smaller than itself combined. Europa's composition is similar to terrestrial planets, primarily consisting of silicate rock. The moon's outer layer is estimated to be around 100 kilometers thick, with part of it frozen as the crust and the rest forming a liquid ocean beneath the icy surface. Recent magnetic field data suggests the presence of a subsurface conductive layer, likely a salty liquid water ocean. Portions of Europa's crust have undergone significant rotation, almost flipping over, indicating that the ice might not be solidly attached to the mantle. Europa is also believed to have a metallic iron core. Its surface is remarkably smooth, lacking significant features like mountains and craters. Recent studies suggest that Europa's equator may have icy spikes called penitents, reaching up to 15 meters high due to direct sunlight causing ice to sublime and form vertical cracks. The prominent markings on its surface are albedo features emphasizing low topography. Few craters are found on Europa due to its tectonic activity, indicating a young and active surface. The surface of Europa is estimated to be 20 to 180 million years old, based on cometary bombardment frequency. However, there is no full scientific consensus on the various explanations for its surface features. Europa's surface is subjected to intense ionizing radiation, making it inhospitable for human beings. The duration of a European day is approximately 3.5 times that of Earth, and its mysteries continue to intrigue scientists, driving ongoing exploration missions to understand its unique characteristics and the potential for life in its subsurface ocean. Europa's surface features include a series of dark streaks called lineae, which crisscross the entire globe. These streaks result from the movement of Europa's crust on either side of the cracks relative to each other. The most likely explanation for these features is that they were produced by eruptions of warm ice as Europa's crust slowly spreads open to reveal warmer layers beneath, similar to Earth's oceanic ridges. Tidal flexing caused by Jupiter's gravity plays a significant role in creating these fractures. Studies suggest that Europa's surface may rotate slightly faster than its interior due to the subsurface ocean mechanically decoupling the outer ice crust from the rocky mantle. This phenomenon, along with evidence of subduction, points to the possibility of active plate tectonics on Europa, making it somewhat analogous to Earth's geological processes. Other surface features on Europa include circular and elliptical lenticulae, freckles. Hypotheses suggest that these lenticulae might be caused by diapirs of warm ice rising through the colder outer crust, akin to magma chambers in Earth's crust. The smooth, dark spots could be formed by meltwater released when warm ice breaks through the surface, while the rough, jumbled lenticulae could be composed of fragments of crust embedded in hummocky, dark material. Recent research has proposed that some of the chaos terrain on Europa might sit atop vast lakes of liquid water, entirely encased in the icy outer shell. These lakes are distinct from the subsurface liquid ocean that is believed to exist deeper beneath the ice. Confirmation of the lake's existence would require further space missions designed to probe the ice shell physically or indirectly, possibly using radar. Another theory suggests that the chaos terrain could be formed from comet impacts penetrating the ice crust and reaching an underlying ocean. Intriguingly, Europa's surface features and geological processes raise the tantalizing possibility of a subsurface ocean, making this icy moon one of the most promising places in the solar system to search for potential extraterrestrial life. Europa is believed to have a subsurface ocean of liquid water, with heat from tidal flexing keeping the ocean in its liquid state. The surface temperature varies from about 110 Kelvin at the equator to 50 Kelvin at the poles, maintaining Europa's icy crust as hard as granite. The evidence supporting the subsurface ocean hypothesis includes the presence of chaos terrain and features like concentric rings and large impact structures. The thick ice model suggests that Europa's outer crust is approximately 10 to 30 kilometers thick, including a ductile warm ice layer, possibly leading to a liquid ocean about 100 kilometers deep. This would result in a volume of water on Europa 2 or 3 times that of Earth's oceans. The thin ice model, however, suggests that Europa's ice shell might be only a few kilometers thick. In this case, contact between the liquid interior and the surface could occur through open ridges or large impacts, potentially exposing the subsurface ocean. Europa has a weak magnetic moment, likely induced by a subsurface layer of highly electrically conductive material, such as a large subsurface ocean of liquid salt water. Spectrographic evidence indicates that the reddish-brown material on Europa's surface may contain salts like magnesium sulfate, possibly deposited by evaporating water from within. There is also a hypothesis suggesting that the colored regions may be composed of abiotic organic compounds called tholins, which have astrobiological implications. The presence of sodium chloride in the internal ocean has been suggested based on observations of a 450 nanometer absorption feature in the chaos regions, thought to be areas of recent subsurface upwelling. The subsurface ocean on Europa presents exciting possibilities for the search for life beyond Earth, making it a fascinating target for future exploration missions. Europa receives thermal energy from three main sources: tidal friction, tidal flexing, and radioactive decay. Tidal friction: ocean tides on Europa generate heat through frictional losses in the oceans as they interact with the solid bottom and the ice crust. Jupiter's tidal forces also induce large planetary tidal waves called Rossby waves due to Europa's small obliquity. The dissipation of this energy could be a significant heat source for Europa's ocean. Tidal flexing: tidal forces from Jupiter and the other moons cause Europa's interior and ice shell to flex, generating heat. The heat produced by the ocean flow due to tidal flexing could be much greater than that generated by the flexing of Europa's rocky core, potentially driving hydrothermal activity similar to undersea volcanoes on Earth. Radioactive decay: Europa's interior may also be heated by the decay of radioactive materials, radiogenic heating, within the rocky mantle. However, the observed heat levels are much higher than what could be produced by radiogenic heating alone, indicating that tidal heating plays a leading role in providing energy to Europa's interior. Recent studies have shown that tidal flexing can generate even more heat in Europa's ice than previously thought, with most of the heat resulting from the ice's deformation rather than friction between ice grains. Overall, tidal heating is the primary source of energy responsible for maintaining Europa's subsurface ocean in a liquid state and driving its geologically active processes, making it a promising destination for further exploration and the search for potential signs of life. Europa, one of Jupiter's moons, exhibits fascinating characteristics that have drawn the attention of scientists and space enthusiasts alike. In 2012, the Hubble Space Telescope captured an image of a potential water vapor plume erupting from near Europa's south pole, suggesting it could be over 200 kilometers high, a significant discovery that has sparked further interest and investigations. The source of heat on Europa comes from several factors, including tidal friction and tidal flexing caused by Jupiter's gravitational forces. This heat generates hydrothermal activity similar to undersea volcanoes on Earth, potentially making Europa geologically active. Europa's atmosphere is thin and primarily composed of oxygen and trace amounts of water vapor, which is produced through radiolysis and non-biological processes. The atmosphere is replenished due to the constant release of hydrogen-oxygen mixture into space. Europa also contains a small magnetosphere, which indicates the presence of a conductive element, likely a subsurface ocean beneath its icy surface. The climate on Europa is extreme, with temperatures ranging from -160 degrees Celsius at the equator to -220 degrees Celsius at the poles. Despite the presence of an atmosphere, Europa lacks weather-producing clouds, wind, and precipitation due to its low gravity. However, studies suggest that its subsurface ocean may contain warm regions, making it a potential candidate for harboring life. Overall, Europa's intriguing features and potential for subsurface oceans have made it a prime target for future space missions, as scientists hope to uncover more secrets about this mysterious moon and explore the possibility of extraterrestrial life beneath its icy surface. Exploration of Europa began with the Pioneer 10 and 11 flybys in the 1970s, followed by more detailed images from the Voyager probes in 1979. The Galileo space probe orbited Jupiter for 8 years from 1995 to 2003, providing extensive examination of Europa and the other Galilean moons. In 2007, New Horizons imaged Europa during its flyby of the Jovian system on its way to Pluto. In 2022, the Juno orbiter also flew by Europa. Future missions to Europa have been proposed and studied, driven by the interest in potentially finding signs of extraterrestrial life or studying its chemical composition. Some of the mission concepts include the Europa Clipper, which plans to conduct multiple low-altitude flybys to explore the Moon's habitability and select potential landing sites, and the Europa Lander, a recent concept mission under consideration. Additionally, the European Space Agency, ESA, is planning a mission called Jupiter Icy Moon Explorer, JUICE, which includes 2 flybys of Europa and focuses more on Ganymede. However, the challenging radiation environment around Jupiter poses a significant technical challenge for any future mission to Europa. In the early 2000s, several ambitious missions were proposed to explore Jupiter's icy moons, particularly Europa. The Europa-Jupiter System Mission, EJSM, was a joint NASA-ESA mission that aimed to send 2 spacecraft, the Jupiter-Europa Orbiter, JEO, led by NASA, and the Jupiter-Ganymede Orbiter, JGO, led by ESA. The mission's launch was planned for 2020, with a focus on studying Jupiter's icy moons and their potential for harboring life. The Jovian Europa Orbiter and the Europa Orbiter were separate concepts that also aimed to explore Europa and its subsurface ocean. The Europa Orbiter, in particular, featured an ice-penetrating radar to scan below the surface. Other proposals included the Ice Clipper, which would have used an impactor to crash into Europa's surface and collect debris for analysis. The Jupiter Icy Moons Orbiter, JMA, part of Project Prometheus, was a partially developed fission-powered spacecraft with ion thrusters, but it was cancelled in 2006. More ambitious ideas involved sending a nuclear-powered melt probe or cryobot to melt through Europa's icy surface and reach the subsurface ocean. Once there, an autonomous underwater vehicle or hydrobot would gather information and transmit it back to Earth. However, these ideas have not yet reached the formal planning stage and present significant challenges, including ensuring extreme sterilization to prevent contamination and false detection of Earth organisms. Europa has become one of the most promising candidates for potential habitability in our solar system. While there is currently no direct evidence of life on Europa, the presence of a subsurface ocean and the energy provided by tidal forces make it a compelling target for further exploration. The under-ice ocean of Europa could potentially harbor life, similar to Earth's deep ocean hydrothermal vents where unique ecosystems thrive. Even if Europa lacks volcanic hydrothermal activity, there are processes like serpentinization and ice-derived oxidants that could produce Earth-like levels of hydrogen and oxygen, providing potential energy sources for life. Scientists have found evidence of salt from the subsurface ocean coating some geological features on Europa, suggesting interactions between the ocean and the seafloor, which is significant in determining habitability. The energy generated by tidal forces on Europa is much greater than any radiological source, making it a significant driver of active geological processes. Life on Europa could exist around hydrothermal vents on the ocean floor, beneath the ocean floor, endoliths, or even clinging to the lower surface of Europa's ice layer. If Europa's ocean is too cold or too salty, only extreme halophiles might survive. Studies propose that Europa's ocean could become oxygenated through processes involving ice irradiation and transport of oxygen and peroxide into the interior ocean, which could potentially support complex, multicellular life forms over time. The presence of lakes and pockets of liquid water on Europa's icy shelf further adds to its potential habitability. Hydrogen peroxide is also abundant on Europa's surface and could serve as an energy supply for simple life forms. Clay-like minerals detected on Europa's icy crust, often associated with organic matter on Earth, raise intriguing possibilities, including the idea of lithopanspermia, where life on Earth could have been transferred to Europa through asteroid collisions. While the evidence points to Europa being a prime candidate for habitability, further exploration and missions are needed to conclusively answer the question of whether life exists on this intriguing moon. Thank you for joining us on this journey of exploration into the mysteries of Jupiter's moon Europa. From its striking surface features to the tantalizing possibility of a vast subsurface ocean, Europa has captivated our imagination and sparked our curiosity about the potential for life beyond Earth. As we've seen, Europa's icy shell conceals a hidden world of possibilities. The evidence of liquid water and the energy provided by tidal forces make it one of the most promising places in our solar system to search for extraterrestrial life. While we may not have all the answers yet, the ongoing efforts of scientists and space agencies to study Europa bring us closer to unlocking its secrets. Future missions like Europa Clipper and others hold the promise of revealing even more about this enigmatic moon. So, remember to stay tuned and keep an eye on the skies, as humanity continues its quest to understand the cosmos and unravel the mysteries of celestial bodies like Europa. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell to be the first to know when we explore other fascinating corners of the universe. This is Cybot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.